In section 3.5, we will solve systems of inequalities. The goals of the lesson are to determine if a point represents a solution to a system of inequalities, to identify a point that represents a solution to a system of inequalities, and to graph systems of inequalities. In the first example, we're given two inequalities, and we want to determine which of the following points represent solutions to the systems. The first thing we want to do is decide which of the two inequalities is going to be the easiest to work with. And I would say definitely the top one is the easiest to work with. Now in the top one, it says that if I add the two numbers together, C and B, that they have to add up to be less than or equal to 60. So when I go through each of these different options, I've got these two adding up to 55, so that would be okay. For B, these are going to add up to 70. That's not going to work for the first inequality. For C, 20 and 10 add up to be less than 60, so that one's okay. For D, that one will work. And then for both E and then F, those are going to be too big. They're going to exceed 60. Then if I look at my other inequality, 6 times 50 is going to give me 300 plus 30 times 5, which is going to be 150. And then if I add those two together, those are going to be less than or equal to 600, so that one will work. Then when I look at option C, 20 and 10, here I've got 6 times 20, so that's 120, plus 30 times 10, which is 300, and those two will add up to be less than or equal to 600, so that's going to work. Then for D, when I get to this one, I've got 60 when I plug in the 10. This is going to give me 600, and those two are going to exceed 600, so D is not going to work. So since A and C worked for each inequality, those will be our answers. Now when we look at number 2, we're going to ultimately place an X in the region which is part of the solution to the system of inequalities below. So what we want to look at first is the top one says C is less than or equal to 420 minus T. And we want to figure out which line that's going to be. Well, this one has a negative slope and a positive intercept. So this is the positive intercept, and it does look like it could be around 420, and it has a negative slope. So I'm thinking already that that line is this one. Now, since it's supposed to be less than, that's going to tell me that the regions that work for that line would be below. The regions that work for this line would be below. So right now I'm looking at these two regions. Now the other inequality is talking about this line, and that's also less than. So below this line is where we would want to shade. And the overlap here where they both would end up being shaded would be in this region here. So the X goes there. Now what we want to look at is which of the following points represent solutions to the system. So any point that falls within this region right here is going to be a solution to the system. And so here, if I look at this, we've got 150, which is here, comma 50. And so it looks like that one is going to be a part of the solution, so A is an answer. For B, we're at 350, comma 50. That also appears to be in the region, so B is going to be a correct answer. Then I look at 50, comma 150, and that is not going to be in the graphed region, so C is not going to work. And then for D, if I look at 250, which is here, comma 150, which is here, that again is in that region, so D is also an answer. So A, B, and D work for number 2. For example 3, we need to graph both of these lines. So y is greater than or equal to 2x minus 5. I start by plotting a y-intercept at negative 5. From there, my slope is positive 2, so I'm going to go up 2 to go over 1 and make a point there. And I could keep going throughout the graph. Then I want to make my line with a straight edge. This is also going to be a solid line because it's greater than or equal to. And then we'll talk about the shading of that line in a few minutes. Now this other one is going to start at 0, and it has a slope of negative 3. So we go down 3 to go over 1. And that ended up right here. Then I could do that again, and then finally I'm going to make that, that line. And that line needs to be dotted because we don't have an equal sign here. So now as we start to talk about shading here, if we look at the blue line here, which is my top inequality, that says greater than or equal to. So there are 4 different regions here. If it needs to be greater than this line, it's got to be above that line. And there's 2 regions out of those 4 that are considered to be above the blue line. Then for my purple line, this one right here, This one says less than. So again, out of these 4 regions, I want to look to see which regions fall below that line. And it's this region and it's this region. So whatever would work for both regions is going to be where we place our X here. And so it's this region over here that would be the final shaded region. Anything that falls within this region would be considered a solution to our system. Example 2, we do the same thing. So for my top line, I'm going to start at +4, and my slope is +2. So up 2 and over 1 is going to put me right around here. And then I can make that line. That's going to be a solid line because it is equal to. We'll come back to the shading in a few minutes. From here, we do need to solve this. We're going to start by subtracting 2x on each side. That cancels this 2x. I get negative y is less than negative 2x plus 4. Then I divide by -1. And I do need to make sure I'm flipping the direction of the inequality because we divided by a negative. And we end up getting y is greater than 2x minus 4. So here I'm going to start by plotting a point at -4. Then it goes up 2 to go over 1. And we'll go ahead and make that line. And that is going to be a dotted line. Now from here, if I go back to the blue line, that said greater than. So there are 3 different regions here. Of these 3 regions, the only one that is going to be considered greater than or above this line is this region up here. Then for the purple one, it's going to be, again, above this line. So that actually falls into 2 separate regions. It falls in here. And where both parts are indicated, that's going to be the answer. And so in this case, it would be this region above the blue line that ends up working for everything. So anything falling in this region right here would be considered a solution to the system. Now on number 3, we can plot that top line. We start at +5, the slope is -1. So down 1 to the right 1, and we could keep going and make that line. Again, that's going to be a solid line because it is equal to. Then for my other line, I start at -4, the slope is +3. So I go up 3 to go over 1, and we form that line. This line is also solid because it is equal to. Now when I start to think about the shading, again, there are 4 different regions that are formed here. And for the one that I have in blue, this says greater than. So greater than means above the blue line. And that would make it the 2 regions up here. So I'm going to indicate that with stars. And then for my other inequality, it states less than. So it needs to be whatever regions fall below this line here. And that would put us in these 2 different regions. So the region that works for both of those inequalities is going to be this region here. So anything that falls in this region would be considered a solution. With this one, we start with y is greater than 5. That's going to tell me to make a point at 0, 5, and it's going to be a horizontal line. And this is going to be a dotted line since this does not include an equal sign. Then for my other one, I'm going to start at -3. We go up 2 to go over 1, and we can make that line, which is also going to be a dotted line. From here, when I'm looking at the different regions, this says greater than. So here I've got 1, 2, 3, 4 different regions. The ones that are greater than are going to be up here. And then for my other inequality, this says less than, so it's going to be in these 2 regions here. Once again, I'm looking for the region that works for both, and that's going to put us here, making anything in this region a solution to our system of inequalities. Now for homework, you are going to work on solving systems of inequalities. There are 3 parts to the Delta Math assignment tonight.